This is problem 5 for the behavioral analysis series or lecture series that are on YouTube. And in this problem, it's taken from Bartles' Intro to Real Analysis 4th edition textbook, and it's exercise number 11 from section 2.3. So the problem is you have some subset of the real numbers S that's bounded. So it's a bounded set, so that means it's bounded above and bounded below, which means it has a supremum and an infimum. All right, so that's what it means to be bounded. So let S naught be a non-empty subset of S. Show that the infimum of S, inf S, is less than or equal to the infimum S naught, less than or equal to the supremum of S naught, and that's less than or equal to the supremum of S. All right, so that's the exercise. All right, so proof. From the previous problem that we just did, so note from problem 4 that I did earlier in this series of problems, we showed that if A is a subset of B, both are bounded above, then supremum of A is less than or equal to the supremum of B. All right, so that's what we showed in problem 4. So therefore we know S naught is a subset of S. S is bounded set, means it's bounded above, bounded below. Since S naught's a subset of a bounded set, then S naught's also bounded above and below. So both are bounded. So they're both bounded above. So then based on this previous problem, then the supremum of S naught is less than or equal to the supremum of S. Also, the infimum of S naught also note that inf of S naught is less than or equal to supremum of S naught. So we have the infimum of S naught less than or equal to supremum of S naught, which is less than or equal to supremum of S. So we almost have the problem already done just based on knowledge from the previous problem and just what we know about infimums and supremums. So the supremum of the set is less than or equal to the infimum of the set is less than or equal to the supremum. So the infimum of S naught less than or equal to the supreme, or sup S naught. And based on problem 4, sup S naught is less than or equal to sup of S. So therefore, all we need to show is the infimum of S being less than or equal to the infimum of S naught. So it suffices to show that inf of S is less than or equal to inf of S naught. All right, because then we have the problem solved. So then we would have inf S less than or equal to imp S naught less than or equal to sup S naught, which is less than or equal to sup of S. Okay, so it's going to be done. This is going to be done how we did problem 4, as far as showing that the imp of S is less than or equal to imp of S naught. Okay, so S naught's entirely contained in S, and first note, inf of S is a lower bound for the set S, and so inf of S is also a lower bound for S naught. Since the set S naught is contained in the set S. So from definition of infimum, we know that well, two things. We know that for all, let's say X and S naught, the X or the infimum of S naught is less than or equal to X. And then for any lower bound, W of S naught, we have W is less than or equal to the infimum of S naught. And we know infimum of S is a lower bound. So because of what was stated earlier in the definition of infimum, so DEF for definition, we have the infimum of S is less than or equal to the infimum of S naught, since infimum of S is a lower bound for S naught, and that was because we know infimum of S is a lower bound for S, and S naught's entirely contained in S. So that, therefore, we finished the proof now. So hence, infimum of S less than or equal to infimum of S naught, less than or equal to supremum of S naught, which is less than or equal to supremum of S. Now I could have, I kind of was just writing my thought process throughout this. You could have definitely written this way less words. So I used the previous problem where you know that if A is a subset of B and they're both bounded above, sup of A is less than or equal to sup of B. Well, S naught's a subset of S. They're both bounded, so they're both bounded above. So then the sup of S naught is less than or equal to sup of S. Also, we know the infimum of a set, that's going to be less than or equal to the supremum. So infimum of S naught less than or equal to supremum of S naught, which is less than or equal to supremum of S. So therefore, all I had to show was that the infimum of S is less than or equal to the infimum of S naught. So to show that, I noted that infimum of S is a lower bound for S, since it's the greatest lower bound of S. And so the infimum of S is also a lower bound for S naught, since S naught's entirely contained in S. And then I use the definition of infimum specifically bullet point 2, where it says for any lower bound W of S naught, W is less than or equal to the infimum of S naught. Infimum of S is a lower bound of S naught, so therefore infimum of S is less than or equal to the infimum of S naught. And then because of that, I have this the string of inequalities in the last line. All right, so that's it for this problem.